Right now, as you're reading this, there's an invisible force field surrounding our entire planet. It extends thousands of miles into space, deflecting deadly radiation that would otherwise sterilize all life on Earth. You can't see it, you can't feel it, but without it, you wouldn't last a week. Welcome to Paradox Labs, and this is what would happen if Earth's magnetic field disappeared. Most people have no idea this shield even exists, but it's been protecting us for billions of years, and there's growing evidence that it's weakening. In some places, it's already failed, and if it disappears completely, Earth won't just become uninhabitable, it will become a dead planet like Mars, stripped of its atmosphere, bombarded by radiation, and left as nothing but a barren rock floating through space. Let me show you exactly how we'd all die. First, let's understand what Earth's magnetic field actually is. Deep beneath your feet, about 1,800 miles down, there's an ocean of molten iron spinning inside Earth's outer core. This churning liquid metal generates electrical currents, and those currents create a magnetic field that extends far beyond our planet's surface. This field, called the magnetosphere, acts like a gigantic bubble that surrounds Earth, stretching from pole to pole. But here's what most people don't realize. This isn't just some interesting geological feature. It's literally the only reason complex life exists on this planet. Without it, Earth would have suffered the same fate as Mars billions of years ago. Mars once had a magnetic field too, but it died when the planet's core cooled. Within a few hundred million years, solar wind stripped away most of Mars's atmosphere, evaporated its oceans, and turned it into the frozen desert we see today. Earth's magnetic field prevents that from happening to us. Every second of every day, it's deflecting a torrent of deadly particles from the sun. The sun isn't just a bright light in the sky. It's a nuclear furnace constantly ejecting a stream of charged particles called the solar wind. These particles, mostly electrons and protons, travel through space at speeds of up to 1 million miles per hour. When they reach Earth, they carry enough energy to fry electronics, damage DNA, and strip away our atmosphere molecule by molecule. But they never reach the surface. Earth's magnetic field deflects them, channeling the particles toward the poles, where they collide with atmospheric gases and create the auroras, the northern and southern lights. It's beautiful, but it's also a constant reminder that we're under siege. The sun also periodically unleashes something far more dangerous: solar flares and coronal mass ejections. These are massive bursts of radiation and plasma that make the regular solar wind look gentle. A large coronal mass ejection hitting Earth today, even with our magnetic field intact, could cause trillions of dollars in damage to satellites, power grids, and communication systems. In 1859, a solar storm called the Carrington event caused telegraph systems worldwide to spark and catch fire. If that happened today, it would be catastrophic. Now imagine all of that hitting Earth with no magnetic field to stop it. If Earth's magnetic field disappeared right now, you wouldn't immediately notice. There'd be no earthquake, no explosion, no visible sign at all. But within hours, humanity would realize something was catastrophically wrong. Satellites would be the first to go. Without the magnetosphere's protection, solar radiation would bombard every satellite in orbit, frying their electronics within hours or days. GPS would fail. Weather forecasting satellites would go dark. Communication satellites would stop working. The International Space Station would become a death trap for any astronauts aboard, exposed to lethal doses of radiation with no way home. Back on Earth's surface, power grids would start experiencing massive fluctuations. The charged particles from the solar wind would induce electrical currents in power lines, transformers, and substations. These currents would overload systems that were never designed to handle such stress. transformers would explode, substations would catch fire. Within 24 hours, large portions of the global power grid would be permanently damaged. No electricity means no internet, no cell phones, no ATMs, no gas pumps, no refrigeration, no water treatment plants. Modern civilization runs on electricity, and the infrastructure to generate and distribute it would be crippled almost immediately. Now let's talk about what happens to living things. Earth's atmosphere provides some protection against radiation, but without the magnetic field deflecting the majority of incoming particles, radiation levels at the surface would begin to climb rapidly. Initially, this wouldn't be immediately lethal. You wouldn't spontaneously burst into flames or drop dead. But every day, you'd be exposed to radiation doses equivalent to multiple X-rays. Your cells would start accumulating DNA damage. Your risk of cancer would skyrocket. Pregnant women would face catastrophically high rates of birth defects and miscarriages. People who spend more time outdoors, farmers, construction workers, anyone without adequate shelter, would receive the highest doses. Within weeks, we'd start seeing the early symptoms of radiation sickness in the most exposed populations: nausea, vomiting, hair loss, and weakened immune systems. But the real danger would be during solar storms. A major coronal mass ejection hitting an unprotected Earth could deliver lethal radiation doses to anyone caught outside. Imagine being told you have to stay indoors for days or weeks at a time, not knowing when the next wave of deadly radiation will hit. Air travel would become suicidal. At cruising altitude, where the atmosphere is thinner, passengers and crew would be exposed to radiation levels hundreds of times higher than on the ground. Airlines would be grounded permanently. Here's where things go from catastrophic to apocalyptic. The solar wind doesn't just bring radiation, it physically strips away atmospheric gases. Without Earth's magnetic field, the upper layers of our atmosphere would begin to bleed into space. This wouldn't happen overnight. Mars took hundreds of millions of years to lose most of its atmosphere, but Earth would start down that same path immediately, and the effects would compound over time. The first gas to go would be hydrogen, the lightest element, then helium. Eventually, even heavier molecules like oxygen and nitrogen would start escaping. Every year, Earth would lose a little more of the protective blanket that keeps us alive. As the atmosphere thinned, surface radiation levels would increase. The ozone layer, which blocks harmful ultraviolet radiation from the sun, would be destroyed. UV radiation at the surface would become intense enough to cause sunburns in minutes, and skin cancer rates would become virtually universal among anyone exposed to sunlight. Plants would struggle to photosynthesize under the constant UV bombardment. Crops would fail. Forests would die. The base of the food chain would collapse, triggering a mass extinction that would cascade through every ecosystem on Earth. Without electricity, without reliable agriculture, and with increasing radiation levels making outdoor activity dangerous, human civilization would fragment rapidly. Cities dependent on complex supply chains and infrastructure would become unlivable. Billions of people would be forced to migrate, seeking shelter in underground facilities or areas with natural radiation shielding. But here's the brutal reality. There isn't enough underground space for everyone. Governments would face impossible choices about who gets access to protected shelters and who gets left behind. Resource wars would erupt. Nations would collapse. The global population would plummet as starvation, disease, and radiation took their toll. The people who survived would be those who could secure space in deep underground bunkers or caves, natural formations that provide sufficient mass between them and the surface to block radiation. These survivors would live like our distant ancestors, huddled in darkness, venturing to the surface only when absolutely necessary and only with heavy protective gear. Over centuries and millennia, Earth would continue to lose its atmosphere. Average temperatures would begin to drop as the greenhouse effect weakened. The water cycle would break down as water vapor escaped into space. Eventually, the oceans themselves would begin to evaporate, with the water molecules breaking apart and the hydrogen escaping into space, while oxygen either escaped or bonded with surface rocks. Within a few million years, a blink of an eye in geological time, Earth would be unrecognizable. The blue marble would become a red desert. The thick, breathable atmosphere would thin to a whisper. Life on the surface would be impossible. Earth would become what Mars is now, a cold, dead world with a thin atmosphere, no liquid water, and only the ghosts of a once thriving biosphere preserved in ancient rocks. Any humans still alive would be living in sealed underground habitats, entirely dependent on technology to survive. They would be prisoners on their own planet, unable to breathe the air or walk the surface without protective suits. And they would be constantly aware that their existence depended on maintaining systems that, once they failed, could never be replaced. Now here's the unsettling part. Earth's magnetic field doesn't just disappear, but it does weaken and flip. Throughout Earth's history, the magnetic poles have reversed hundreds of times, with north becoming south and south becoming north. During these reversals, the field weakens significantly and can even briefly disappear entirely. The last reversal happened 780,000 years ago. We're overdue for another one. And in recent decades, scientists have observed that Earth's magnetic field is weakening at an accelerating rate. In some areas, particularly over the South Atlantic, the field has weakened so much that satellites passing through that region experience glitches from radiation exposure. The European Space Agency's swarm satellites have been monitoring these changes, and the data is concerning. The field is weakening about 5% per century on average, but in some regions it's declining much faster, up to 10% per decade. Does this mean a reversal is imminent? Not necessarily. The field has fluctuated before without flipping, but it's a reminder that the shield protecting us isn't permanent and isn't invulnerable. So what would happen if Earth's magnetic field disappeared? In the immediate term, our technology would fail and radiation levels would skyrocket. In the medium term, society would collapse as agriculture failed and billions died. In the long term, Earth would lose its atmosphere and become a dead planet, incapable of supporting life on its surface. The magnetic field is the invisible thread holding our entire world together. We don't think about it. We don't see it. Most people don't even know it exists. But it's the difference between Earth and Mars. It's the difference between a living world and a dead one. And right now, it's getting weaker. We can't control Earth's magnetic field. We can't strengthen it or prevent it from flipping. All we can do is monitor it, prepare for the consequences, and hope that when the next reversal comes, and it will come, humanity is ready to survive what could be the greatest challenge our species has ever faced. Because without that invisible shield, we're just fragile biological organisms on a rock in space, completely at the mercy of a hostile universe. And the universe doesn't care if we make it or not.